September 2022. Jensen Huang, the leather-clad patriarch of NVIDIA, stood on a digital stage to unveil a miracle. He promised a world where performance was no longer bound by the physical limits of silicon, but by the infinite imagination of artificial intelligence. With the click of a button, frame rates didn't just double, they quadrupled. The RTX 4090 was presented as a god-tier monolith, a card so powerful it could invent reality out of thin air. In less than 2 years, this technology has migrated from a high-end luxury to an industry-standard requirement, infiltrating every major release from Cyberpunk 2077 to Alan Wake 2. But beneath the shiny benchmarks and the magic of AI lies a cynical shift in the very fabric of software engineering. A world where native resolution is dying, input lag is being masked by clever algorithms, and developers are using AI as a high-tech crutch to avoid the grueling work of optimization. We've traded raw power for a hallucination, and the cost is a gaming experience that looks fluid on a graph but feels hollow in your hands. This is the story of the fake frame revolution and the toxic truth behind the numbers on your screen. The illusion began with a simple problem. Moore's law was finally hitting a wall. For decades, we lived in an era where transistors got smaller, chips got faster, and performance gains were a matter of brute force. If you wanted more frames, you bought more silicon. But as we reached the sub-5N level, the heat became too intense, the yields became too low, and the price of production skyrocketed. The industry was staring into a stagnant abyss. NVIDIA's solution wasn't to build a better engine, but to build a better magician. Deep learning super sampling was born, a way to render a game at a low, blurry resolution and use AI to guess what the high-res version should look like.
It was a brilliant patch for a dying era of hardware growth, but it opened a Pandora's box of corporate shortcuts that would eventually redefine what we call performance. When frame generation entered the chat, the magic trick became a full-blown deception. Unlike upscaling, which just sharpens an existing image, frame generation, DLSS3 and FSR3, actually creates entirely new images and inserts them between the real ones. These frames have no soul. They aren't calculated based on your mouse movements or the game's internal logic. They are hallucinations, visual filler designed to trick your eyes into seeing smoothness that isn't actually there. On a YouTube benchmark, it looks incredible. You see the number 144 FPS in the corner, and your brain celebrates. But when you actually sit down to play, something feels off. You are seeing 144 frames per second, but you are only feeling 60. The input lag, the time between you clicking the mouse and the gun firing, remains tied to the real frames, not the fake ones. We've effectively separated the look of a game from the feel, turning modern titles into interactive movies where your input is an afterthought. The dark underbelly of this shift is how it has metastasized into the development cycle itself. In the before times, a developer's primary job was optimization. They spent months, sometimes years, squeezing every ounce of power out of the console hardware, using clever coding and memory management to make games run smoothly. But today, that discipline is evaporating. Why spend millions of dollars on optimization when you can just slap a DLSS required sticker on the box? We are seeing games launch in fundamentally broken states. Starfield, Cities Skylines 2, Remnant 2, where the minimum specs assume you're using upscaling and frame generation just to reach a playable 30 or 60 FPS.
The fake frame has become a silicon band-aid for lazy engineering, a way for publishers to rush unfinished products to market while letting AI hide the cracks in the code. This is the optimization crutch in its purest form. When a game like Remnant 2 launches and the developers explicitly state that the game was designed with upscaling in mind, it signals a surrender. It means that the native resolution, the actual pixels being drawn by the GPU, is no longer the target. We are now paying $1,600 for high-end graphics cards just to see an AI's best guess at what a game should look like. It is a massive transfer of power from the artist to the algorithm. The visual cost is real. Ghosting artifacts behind fast-moving objects, shimmering fences, and UI elements that flicker like a dying neon sign. For the sake of a higher number on a bar chart, we have accepted a degradation of visual clarity that would have been laughed out of the room 10 years ago. Furthermore, the fake frame economy has created a tiered class system in gaming. If you aren't owning the latest $800 plus GPU with proprietary hardware optical flow accelerators, you are being left behind in a wasteland of stuttering software. Features like DLSS 3 are locked behind hardware gates, forcing a planned obsolescence that feels more like a ransom note than a technical limitation. AMD's FSR 3 has tried to democratize the technology, but even there the quality gap is noticeable. We are moving toward a future where medium settings at native resolution is a relic of the past, replaced by a confusing mess of quality presets, ultra-performance toggles, and frame-gen switches that most casual gamers don't even understand. The psychological impact on the consumer is perhaps the most cynical part of the story. We are addicted to the number. The industry has conditioned us to believe that more FPS always equals better game, regardless of how those frames are produced.
It is a classic quantity over quality trap. We celebrate a 200 FPS benchmark while ignoring the fact that the image is a smeary mess of upscaled artifacts and interpolated frames. It's the digital equivalent of a pink slime burger. It looks like meat, it's shaped like meat, but it lacks the nutritional value of the real thing. We are consuming empty frames that provide no tactile benefit to the player. And then there is the energy cost. Generating these fake frames requires immense computational power, drawing hundreds of watts from the wall. We are burning real-world electricity to generate imaginary images that don't even respond to our input. In an era of climate consciousness and rising energy costs, the fake frame revolution is a monument to excess. It is a high-tech solution to a problem that developers used to solve with better math and tighter code. We've replaced human ingenuity with an AI-driven power chug, all to maintain the illusion that hardware is still getting faster. As we look toward the future, the question isn't whether fake frames will disappear. They won't. They're too profitable, too convenient, and too baked into the current hardware roadmap. The real question is whether we'll ever get back to a world where a game's performance is an honest reflection of its engineering. Or are we destined to live in a perpetual hallucination where every game is just a low-res smudge being hallucinated into glory by a corporate AI? We are currently in the honeymoon phase of this technology, blinded by the sudden jump in numbers. But as the artifacts pile up and the input lag becomes undeniable, the magic is starting to wear off. We are being sold a dream of infinite performance, but the reality is a nightmare of compromises. We've handed the keys to our visual medium to a black box algorithm that doesn't care about artistic intent or tactile response. It only cares about the math.
Every time we toggle frame generation on to fix a poorly optimized port, we are voting for a future where optimization is dead. We are telling the industry that we don't care if the frames are real as long as the counter in the corner says 144. This is the story of the pixels that weren't there. a $100 billion industry's attempt to fake its way out of a technical dead end.